In the last video for this week, I want to talk about the last couple checks that you can add on SQLite to ensure that you don't add bad data or change data in the database to be bad. Now, what is bad? We'll talk about that in a little bit. So first, we're going to have an example where we have two tables here. We have the tracks table, which has a ID for each song in our database, the name of the song, as well as a artist ID, which represents the artist that created this song. The artist ID is the ID of the second table here named artist. It has an ID, and all those artists also have names. So what this database means is, hey, look, these three songs all have artist ID 1, which matches with the artist ID in the other table, saying that these three songs were made by the Beatles. Hedwig's theme was made by artist ID 2, who happens to be John Williams. The Devil is a Patient Man happens to be a song by the artist Crud. And in fact, Jingle Bell Rock doesn't have any artist in the artist table to match to. The term for this artist ID in the table tracks here is a foreign key. It is saying that tracks.artistid is a foreign key referencing artist.id, that for every value here, it should have a match to here, unless of course it's null. So to be a bit more explicit, what is a foreign key? Well, we talked about primary keys, right? Primary keys are the columns that uniquely identify each row. However, there's often the case that we have columns in a table that are meant to match up with columns in a separate table. And so what we often want to do is add a constraint, a rule that says the columns there must be associated with a row in a foreign other table, that every artist ID in the tracks table must actually have a corresponding row in the artist table. However, nulls are okay as foreign keys. It basically says, oh, by the way, this one doesn't have a match, and we're being very explicit about that fact. So how do you denote foreign keys? Well, in our example before, we create a table named artist, and we have integer and name. So that's our table that was on the right here. The tracks table is a little bit more complicated. The first thing is it has its own ID, which is an integer. It has its name, which is a text. It also has its artist ID, which is an integer. And then we add this extra rule here that says, oh, and by the way, there is a foreign key here. Artist ID, the column right here, references this other table, artist, and the column ID there. So it's saying artist ID here points at this other table. Okay, so what do we do here? Well, with a foreign key, it becomes an error to change the database in a way that makes a row not match with the row that's being referenced. So that means if you insert a row that doesn't have a corresponding row, if you update a row to change to point at something that doesn't exist, or if you delete rows from your foreign table such that you now have rows in your table that don't point correctly, those are all errors, and the database will refuse to let you do those things. However, checking for this error is expensive. It means every time you modify either of these two tables, you need to make sure that this rule always holds. And so by default, SQLite doesn't actually check foreign keys for correctness. It will let you break that foreign key statement unless you specifically turn the functionality on by adding pragma foreign keys equals on to the beginning of your SQL statements. So for instance, here, pragma foreign keys on, we can insert into artists the name 1 and Beatles, and now we can insert tracks into our table. So the first value here, 1 Jingle Bell Rock, null, that's okay because null is always acceptable as a foreign key. Here we're adding another song, Let It Be. Its artist is ID 1, which is Beatles. That is something in the other table. That's fine as well. However, if we add Jurassic Park with a artist ID of 2, it will go, that is not okay. There is no matching key. There's no row in the artist table that has the artist ID of 2. Right now there's only one thing in there, and that's the one for Beatles. All right, so that's how to add foreign key constraints. The last constraint you can add to a table, and it's also the most useful one, is called check. All this does is it specifies what legal values can be inserted or updated in a particular table. It's added to a column or after the columns. I'll show you the syntax for this. They both are equivalent. So for instance, let's say we're creating a table called students. All the students have a name, they have an age, and I'm going to add a specific check requirement that says the age must be greater than 18. If you ever try to add a row that has a student younger than or equal to 18, or if you ever try to change a row such that the age is now 18 or lower, it will cause an error. We can also say, hey, by the way, I want an additional check, and this is just by itself, saying, hey, names are not allowed to be empty, and ages must be less than 1,000. We don't allow any immortals in our class. Okay? So how does this work? Well, it's fine until we try to start inserting values in. So if I try to insert Josh, who's 27, is that okay? Yeah, it passes the integer check. Age is greater than 18. It passes the name check. Name is not empty. And it passes the 27 is less than 1,000 years old. So we're okay. This is a value that can be inserted into the database. This next one, though, is an error. Why? Because the name is empty, so that check fails. It won't allow you to insert this row into the table. Also, if Tyler suddenly took a de-aging potion and became 4 years old, I wouldn't be allowed to add Tyler to the class either, because, once again, that violates the constraint on age. Another thing that could cause an error is the update statement. So if I say update students set age equal to, it's over 6,000, what this means is it tries to change all of the rows in the table to have a really large age. That will cause the check to fail, and it will not allow that update to take place. Okay, so foreign keys and checks are actually very similar to each other. So for instance, in our previous example, we checked to say foreign key artist ID references artist ID. Okay, saying the artist ID column in this table better have a match in the artist table. This is exactly the same thing as check if the artist ID is null, or there exists a row in artists where the tracks.artistID, the artist ID that we're looking at, is equal to the artist.id in the other table. It's basically saying, make sure that there is a row in the other table. Okay, so with that, we'll go to our multiple choice question. When should you use a foreign key constraint? So it's a little bit of a tricky question. Really, the time you should be using a foreign key is when you have a column that better have a match in a different table. So really the second answer there. And especially when you want to make sure that that's enforced, make sure that the database checks for that and make sure that that happens so that you don't screw up. You don't change your database in a way that when you try to, for instance, join those two tables together, that you don't get a nice, proper, complete join.